Good morning, all of you. So today's topic is graph coloring and graph covering. So what is graph coloring and how we find a color of a graph by the concept of chromatic number. So first coming to definition of graph coloring. So let G be a planar or non-planar graph if we assign colors to its vertices in such a way that no two adjacent vertices have the same color. So the condition is in a graph, no two adjacent vertices has the same color. Then we say that the graph is properly colored. Then we say that the graph is properly colored. Okay. In other words, so let G be a given graph. Let G be a given graph, and now we have to assign color to each and every vertex of a given graph with the constraint that no two adjacent vertices have the same color. So that is called properly colored graph. Okay, if in case of two adjacent vertices have same color, then we say that the graph is not properly colored. Okay, so here properly colored means assigning colors to its vertices such that no two adjacent vertices has the same color. Okay, so let us consider an example. So in this graph we assign, so this graph has 5 vertices here. So let us take v1, v2, v3, v4, v5. So we assign color to vertex v1 is red. Okay, so next we have to assign color to v2. So if we assign here red color, adjacent vertices means v1, v2, these two are adjacent vertices. So if we have to assign properly colored, the condition is no two adjacent vertices is same color. So now we assign another color that is blue. Okay, so here v1 is assigned to red color and v2 is assigned to blue color. Next go to v3 vertex. If v3 vertex is adjacent to v2, so here not assign blue color. So whatever we use in to assign in vertex v1, it is used to vertex v3 because these two vertices are not adjacent. Okay, so we assign red color to v3 vertex and go to v4 vertex. Here we assign another color because, so suppose if we take, so here we assign the color green. Okay, so next here assign green to v5 vertex. So we have to check any two adjacent vertices has different colors. So these are two adjacent vertices. So here the colors are red and green. These two adjacent vertices colors green and red, and these are adjacent vertices and these colors are red and green. These two are red and blue. So this graph is properly colored graph. So a graph can have more than one proper coloring. Two non-adjacent vertices in a properly colored graph can have the same color. So two non-adjacent vertices in a properly colored, that means here we consider v1 and v3. These two are non-adjacent vertices. So these two have the same color. Okay. So what is graph coloring? In a given graph, a graph is a collection of vertices and edges. Now we have to assign color to each and every vertex of a given graph with the constraint that is no two adjacent vertices have the same color. So that is called properly colored graph. Okay. So another examples. So this is a graph of four vertices. The four vertices A, B, C, D, and now we assign a color red to A vertex and assign blue to B vertex, and then we assign red. Why? Because A and D are not adjacent vertices, and we assign C to color blue. So here B and C are not adjacent vertices. So the colors, the this is by using two colors to assign total vertices. So this graph is called two colorable graph. So number of colors used is equal to 2. Okay. So next, in this graph, it has 5 vertices. So A, B, so 4 vertices, sorry, 4 vertices. So A, B, C, D, and 6 edges. 1, 2, 3, 4, 5, 6 edges. Okay. So now we assign red color to A and blue color to B and green to D. Why? Because if we assign red color to D, A and D are adjacent vertices here. So there is an edge between A and D. So we do not assign red color to D vertex. So we choose another color, that is green. Okay. So next we assign yellow color to C because B and C are adjacent vertices here. So we assign a different color, that is yellow. So this is 4 colorable graph. Number of colors we used is 4. Okay. So next, another one. In this graph has 5 vertices. So now we assign red color to A and blue color to B and C color to red because A and C are not adjacent. So we choose already existed color. So that is a red. Okay. So blue is these two are adjacent vertices. So we assign only red color. The possible to assign is red color. Okay. So next we assign blue color to D. Okay, blue color to D. So we check here another vertex E. If we assign red to E, E and A are adjacent. If we assign blue to E, D and E are adjacent vertices. So we need to assign one more color, that is green. So totally we use 3 colors to assign properly for this graph. So this graph is called 3 colorable graph. So number of colors are used is equal to 3. Okay. So next one. So this is 6 vertices graph. So here we assign red color to A and blue color to B and C color to red because A and C are not adjacent. There is no any edge between A and C, and D color to blue. So B and D are not adjacent. No edge between B and D. And next we assign E to E for red. So and this is not adjacent for A and C. Okay. Next we assign blue color to F vertex. So this is not an adjacent to uh, before coloring vertices blue and B and D. So F is not adjacent to B and D. So now we assign the color blue to F vertex. So totally we use 2 colors to assign all the vertices of the given graph. So this graph is called 2 colorable graph. So number of colors used is equal to 2. Okay. So the condition of the coloring is no two adjacent vertices have the same color. So adjacent vertices means, so here in this graph, A and B are adjacent vertices. A and C are not adjacent vertices. Suppose it has an edge between these A and C vertices. So those vertices also become adjacent vertices. So here no an edge between A and C. Okay. So A and D are adjacent vertices. A and F are adjacent vertices. A and B are adjacent vertices. Okay. So properly coloring means assigning colors to its vertices such that no two adjacent vertices have the same color. That is called properly colored. If in case of two adjacent vertices have same color, then we say that the given graph is not properly colored. Okay. Next definition, graph covering. Graph covering. So in a graph G, a set of edges E is said to be cover of G. A set of edges E is said to be cover of G if every vertex in G is incident and at least one edge in E. At least one edge in E. So in other words, if we have a graph G, from that we define an edge set E. We define an edge set E from the given graph G. So in that every edge, every vertex of G is incident and at least one edge in E. So a set of edges that covers a graph G is called an edge covering or a covering subgraph or simply a covering of G. Okay. So let us consider an example. So in this graph has four vertices A, B, C, D. Okay. So here if in which G have four vertices and we pick a set of edges, if that is E is equal to AB is an edge and CD is an edge. So in this edge set, all the vertices of G are covered. That means A and B and C and D. So this is a cover of G. So we consider another edge set, that is EAC and BD. This edge set is also a cover of G. So here all the vertices A, C and B, D, all the vertices of G, E are covered. So this edge set is cover of G. So these two edges sets are cover of G. So what is graph covering? In a given graph G, a set of edges E is said to be cover of G if every vertex in G is incident at least one edge in G, one edge in E is called graph covering. Okay. So by observations of graph covering, a graph G is its own covering. A graph G is its own covering, means all the vertices are considered edge set. Okay. So using this example, this is the example. This graph is example for this statement. So a graph G is its own covering, and a Hamiltonian graph or Hamiltonian circuit in G is also a covering in G. Covering exists in a graph G if and only if G has no isolated vertex. So isolated vertex means it has no edge. So without any edge, how we define graph cover? So covering exists in a graph G if and only if G has no isolated vertex. Okay. A spanning graph in a connected graph G is also a cover of G. A spanning graph in a connected graph G is also a cover of G. So next one, chromatic number. So what is chromatic number? So how we find a color of a graph? How we find a color of a graph? By the concept, by using the concept chromatic number. Okay, so the chromatic number of a graph is the minimum number of colors required with which the graph can be properly colored. So minimum number of colors required with which the graph can be properly colored. The chromatic number of a graph G is usually denoted by xi of z. Xi of z. So the chromatic number of a graph is the minimum number of colors required with which the graph can be properly colored. So the chromatic number of a graph can be denoted by xi of z. So find the chromatic number of the following graphs. So, so in the first graph, so this graph has how many vertices? 6 vertices. So we use minimum number of colors to assign minimum number of colors. Okay, so first assign vertex v1 to blue color and vertex v2 to red color, and again assign the possible color is blue because vertex v1 and v3 are not adjacent. Okay, and next assign red color, and next assign blue color, next assign red color. So here blue red, these two are adjacent and different colors. Red blue, these two are adjacent and different colors. Blue red, different colors, and red and blue, these two are adjacent and different colors. Blue and red, these two are different. So we assign colors to this graph properly. So the chromatic number of this graph is, how many colors we used? 2. So the chromatic number of this graph is 2. So the chromatic number of the graph G is xi of z, that is equal to 2. Okay. Next, in second graph, so second graph has 5 vertices. So if we assign a red color at vertex v1 and assign blue color at vertex v2 and assign a green color at vertex v3, because blue and green, this vertex is adjacent, and red and this vertex is adjacent. So here we have to assign different color, that is green. Okay, so there is a condition, that is if a given graph has triangle, if a given graph has a triangle, that need to assign 3 colors. Okay, that need to assign 3 colors. So here this is a triangle. So these these vertices are adjacent to each other. So here we assign red color, blue color and green color. So next to go for another vertex v4. So here we assign blue color. So because if we assign red color, these two are adjacent. If we assign green color, these two are adjacent. So we use blue color here. And next we use different color pink, because if we assign red here, these two are adjacent. Green, these two are adjacent. Blue, these two are adjacent. So we assign different color, that is a pink. So totally how many colors are used to assign this graph? 4 colors. Okay, so the chromatic number of minimum colors, how many colors we use? 4 colors. So uh, the chromatic number of a graph G1 is, xi of G1 is equal to 4. Okay, so chromatic number of a complete graph. So chromatic number of a complete graph. So what is complete graph? What is complete graph? In which exactly one edge between each pair of distinct vertices. So every vertex is connected with another vertex in a graph. So a simple graph in which there is exactly one edge between each pair of distinct vertices is called a complete graph. We have to color all the vertices of a complete graph by using minimum number of colors is called chromatic number of a complete graph. Okay, we have to assign colors to all the vertices of a complete graph by using minimum number of colors. That minimum number is called chromatic number of a given complete graph. Okay, so a complete graph with n vertices is denoted by kn. The following figures show the complete graphs from k1 through k6. K1 through k6. So if a given graph with no edge, that means it is isolated vertex. No edge, that means isolated vertex. So this is called one chromatic graph. One chromatic graph. Okay. So if a graph contains only one edge. So to assign colors to this graph, we require two colors. We require two colors to color properly. So this is called two chromatic or bichromatic graph. Okay, two chromatic or bichromatic. So a graph, a complete graph has a n vertices. This is a complete graph. That means so V1 is has an edge with another vertices. V3 has an edge with another vertices of the given graph. So this is a complete graph with three vertices. So a complete graph has n vertices. We need n chromatic. That is called n chromatic. In if we have to require three colors to assign properly. Okay. So this triangle need three colors to assign properly. So the chromatic number of a complete graph K1 is 1 and chromatic number of a complete graph K2 is 2 and the chromatic number of complete graph K3 is 3. So this is called one chromatic, bichromatic and triangle and chromatic. So here 3. So the chromatic number of complete graph is 3. So next consider four vertices. So we assign red color to V1 and blue color to V2 and green color to V3 because here these two vertices has an edge. So these two are adjacent vertices. These two are adjacent vertices. So we need to minimum number of colors 4. So the chromatic number of this graph is 4. And here this is complete graph with 4 vertices. So and this is complete graph with 5 vertices. So V1 there is an edge between V1 to V2, V1 to V3, V1 to V4 and V1 to V5. So we need to assign red color to V1 and next blue. So these two are adjacent. So we assign different color and pink. These two are adjacent and these two are also adjacent. So we go for new color that is pink and green. So these two are adjacent and these two are adjacent and these two are adjacent. So we assign with the new color green and here gray. So all the vertices are assigned with different colors. So So the chromatic number of this vertex is 5. Okay. So here 6 vertices, and we need to assign minimum number of colors are 6, because this is a complete graph with 6 vertices. So red, blue, pink, brown, green, gray. Okay. So the chromatic number of a complete graph K6 is xi of K6, that is equal to 6.